Here's a start at implementing our compile function. We take an exp and we're supposed to produce an xd. So in the int d case, we just produce an int d, and it's similarly straightforward for plus and multiply, where we recur with compile to compile sub-expressions and build up plus d and multi d instead. The first interesting case is IDE here, where we have a name and we need to turn that into a number. And right now, as I've written compile, we don't have enough information. We don't know whether this is a free variable or where it would be in the environment at runtime because we don't have enough context. So that's why our compile forms here have had these ... dots. We need an environment, or at least a shadow of the runtime environment, to tell us where names are going to be. So my compile function takes an env argument, but it's an envc instead of an environment. That is, it's a compile time environment that we use just to find the names. And to use that envc, I'm going to have a helper function called locate that will look for a name in the compile time environment and give me a number back, and then I wrap that as an @d to make it an xd. So how do names get in this environment anyway? Well, the only place where we introduce names is in a function. So at interp time, we add to the environment when we call a function. But in terms of just looking at a function body and deciding whether names are available, it's when we start looking at the body expression to compile it that we add this name as one of the ones that are available. In particular, we add it to the front of the compile time environment. So here I'm using extend_env, which is really just cons, to extend a compile time environment, and I extend it with bindc just having a name. So the bindc constructor is the compile time variant of bind. It has only a name and no value because we don't get values until we interpret. And we don't need the value anyway, we just need the name to figure out where it's going to be in the environment. Meanwhile, function calls are just like plusy and multi, you just compile the sub-expressions in the same environment. But going back to this locate and compile time environment, the locate is going to take a name and an environment, which is a list of binding Cs, and a binding C has a bind C constructor, and it's going to find that name in the environment and report its position in terms of how deep it had to look in the environment. That is, if the environment is empty, this is a free variable, and we can report that at compile time. But if it's not empty, maybe that first binding there has a name matching the one we're looking for. If it does, then that's offset 0 in the environment. If it doesn't, we look in the rest of the environment and the index relative to the rest of the environment. To translate that to the full environment, we just need to add one more back to it. Those are our helper functions for compile. After we've compiled an expression, we're ready to interpret it. So we change our interpreter now to take an xd instead of an exp. And we also change the environment representation to be just a list of values, since we no longer need the names associated with those values. Interp on an xd has cases like int d, plus d, and multi that work pretty much the same as they did for int e, plus c, and multi. But then instead of IDE, we have @d with a position. We can use that position with the primitive list_get referencing operation to look in the environment at that position and get the value directly. Meanwhile, function d still creates closures, just like fun_e did, but the closure no longer needs the name, so we just have a closed v with two parts, expression and environment for the body of the function. Finally, function calls work pretty much the same as they did before. The difference is that when we used to call extend_env with a bind, now we just call cons with the argument value, using the environment, which is just a list, from the closure to build on. Let's see how this looks when we put it all together. For comparison, we have the old direct style interpreter, where we have just the exp data type, including an if0e case because that's useful for examples. And we have the interpreter that works directly on exp with the lookup function to look up variables by name. I have all the usual tests, and I also have this timing test here at the end, where I can measure how long it takes to interpret this Mo expression 10,000 times. And on my machine, that takes about 90 milliseconds. Here is our new version of the interpreter that involves a compilation step. So we've got exp, and parse still produces exp, but our compiler now changes that to an xd through this compile function right here. And our interpreter works on xds, where instead of a lookup function, we just use list_get directly. I have all the same examples down here, except now instead of checking interp of parse, it's interp of compile of parse, where we compile using this compile time environment and run just using a straight list of values as the environment. And I've got that same timing test here at the bottom that when I run it takes about 50 milliseconds to run the program. So we see a significant speed up from 90 milliseconds to 50 milliseconds. Now you should not take that speed up too seriously because we're running inside of Dr. Racket. There are all sorts of extra effects here from debugging annotations and so on. But this represents using a lower level machine operation to get at the values of an environment, and it's no coincidence that even inside of Dr. Racket we can see a significant difference by this change.